As we started to talk about last time, ratios and proportions are everywhere in science. So in order to understand science concepts, we've got to understand them. For example, you find ratios and proportions in gears, in faces and other body proportions, in molecules and the atoms that make them up, in leaf patterns and other biological features, in how far you can hit a baseball, and in pressure, density, and power. All of those are made up of ratios. So even though students have been exposed to these concepts, and some might feel they fully understand, most, it turns out, have significant gaps in their understanding. And what we're trying to do is erase those gaps. So let's start out by taking a look at some of those understandings and potential misunderstandings. Say you have a ratio of 2 to 3, a fraction of 2/3, and we say that it's equal to x over 6. How would we solve for x? Well, you might notice that to get from 3 to 6, you'd multiply by 2. So in order to keep the fraction the same, we would have to multiply the top by 2 as well. And that gives us x equals 4. So that's pretty straightforward. Let's look at one that's a little more interesting because it looks like it doesn't have a ratio on the left, only on the right. But you probably will notice the factor family and can presume that 30 over 6 would give us 5, so x is going to be equal to 30. More people, in fact many adults, have trouble with this one. 5 equals 6 over x. Here, the most common conclusion people jump to is still that x equals 30. But that shows a misunderstanding of the meaning of the ratio. X is not 30, and we're going to take a closer look at this equation a little bit later. But it is time to investigate and to explain what a ratio really is. So let's look at this symbol. What do you see? A division symbol? Or a dot over another dot? Well, it's both. It's a ratio and a division sign, because dividing is making a ratio. If we look at this example of 1 divided by 3, that means, say, that you're going to have a pizza divided equally between 3 friends. 1 divided by 3. So to make that happen, you cut the pizza into 3 pieces, and you give 1 slice to each person. Therefore, everyone gets 1/3 of a pizza, and you can see that fraction there, 1/3. And at the same time, it means that for every 3 pieces there were, you get 1. And that's the ratio. It means for every 3, you get 1. Now here's a question. Could you ever have a ratio where the numerator is larger than the denominator? Sure, that's no problem at all. Here you see 10 over 2. Now, what is this ratio telling us? Well, any ratio is a defined relationship between 2 numbers that tells you that there are blank of these for every blank of those. So in our case of 10 over 2, perhaps we're talking about stars. There are 10 points for every 2 stars. Now, you'll hear and see ratios shown in different ways. 2 might be 1 to 3 or 1:3. These mean the same thing of the ratio relationship. There's 1 of something for every 3 of another. Alright, so we got the ratio and the ratio symbol down. What if we just tilt it a little bit? Does this look like anything you know? What if we add some centers to those circles? Yeah, it's a percent. And a percent is nothing more than a ratio. Let's look at 25%. 25%. Cent meaning 100. So 25 per 100. Or written as a fraction, It's 25 over 100. And we know that this ratio means you get 25 for every 100 of something. But most of you would recognize that this is not a simplified fraction, and that we can actually write it in a different form. So let's look at how we would change this to the reduced form. If we were to look at what this fraction is equivalent to, I noticed that both 25 and 100 could be divided by 5. So let's see, that would give us 20 on the bottom, and if we have to divide the top by the same, we would get 25 divided by 5 is 5. Now we're still not simplified. We could divide this by another number. Turns out we can do 5 again. So if we divide that by 5, we get 4, and if we divide the top by 5, we get 1. So we have our reduced fraction or ratio, meaning you get 1 for every 4. And this is equivalent to getting 25 for every 100, or 25%. All right, let's look at decimals now. So decimals, just like percents, are ratios. When we have something like 0.2, another way of saying that, as you probably have learned in lower grades, is 2/10, because this is the tenths place, and there are 2 of them. So we can write it as 2 over 10, 2/10, a fraction and a ratio. And you can do it with any decimal. Here we have 0.08. So now we're looking at the hundredths place. So this is 8/100ths. And we can write it as 8 over 100. And we can move all the way out to the thousandths place. So here we have 64 thousandths, written as 64 over 1,000. So it's as simple as that. Decimals are fractions. Decimals are ratios. The trick can be when you want to reduce that fraction into its simplest form. So we want to know what's the simplest fraction or ratio for 0.064. Well, we start with our 64 over 1,000. And that's going to be equivalent to some fraction if we can divide both the numerator and the denominator by the same amount. Here we can divide, I know we can divide them both by 4. Here we get 1,000 divided by 4 is 250. So what is 64 divided by 4 going to be? 16. So here we have 16 over 250 is another ratio that's equivalent to 0.064. Now let's reduce it again. Let's divide them both by 2. That's going to give us 8 on the top and 125 on the bottom. Turns out nothing else can go into both those the numerator and the denominator. So here is our simplified fraction, our ratio of 8 over 125, which is the exact same as 0.064. Now you've learned the solid fundamentals of ratios, and you've actually gotten a peek at what a proportion is too. But next time that will be our focus. We'll define it, and we'll do some more serious work with proportions.